Which of the following is an electrophile? So to answer this problem, we need to recall what is an electrophile. So electrophile literally means electron loving. So this is something that has a lack of electrons. And that is why it wants to gain some more. And so to recognize a lack of electrons, we should actually be able to pick this out fairly easy, because what we're going to see is either a positive charge, a partial positive charge, or an incomplete octet. And so with that information, we should fairly quickly recognize that D here, this carbocation, is an electrophile. And this is a common electrophile that we are going to encounter as a reactive intermediate in a lot of organic mechanisms, right? And so another way to describe an electrophile is also as a Lewis acid, right? Because it's going to be an electron pair acceptor. And so while we are looking at this definition, we might as well look at a nucleophile as well, just to make sure that we can recognize both. So nucleophiles then are Lewis bases. And so that means that they have an electron pair that can be donated. And so we can recognize nucleophiles by looking for an electron pair that can be donated. So we will see lone pairs of electrons often acting as nucleophiles. So that's going to be quite often on things that are not carbons. We call those heteroatoms, such as the sulfur here. Those lone pairs of electrons can act as a nucleophile. And also on the oxygen. And especially with the negative charge, this makes this a stronger nucleophile than if it were neutral. So this is a fairly strong nucleophile. Right, so we recognize that as lone pairs of electrons. Also electrons in pi bonds. And where we'll see this is carbon-carbon bonds. So we're going to see things like alkenes and alkynes can act as nucleophiles. And so this alkene then can act as a nucleophile. And specifically, we're talking about the pi bond.